Alright, here we go. More stuff with linear equations. I guess I should have drawn this on there before I started wasting time here. Alright, we're going to do what we call a system of linear equations, okay? And what that means is I have two linear equations. Okay, I have two linear equations, and I want to find the solution to this system of equations. What a solution means is, if I were to draw this line and this line, where do they meet on the graph? There's a specific point where they're going to meet. So let's get a visual idea and then tell you how to solve it algebraically. So I'm going to just give real rough sketches just to give you the idea. So 1/2 x plus 4, we'll say plus 4 is right there. Up 1 over 2 is going to look something like this. Okay, that's going to be this line, y equals 1/2 x plus 4. This one, 3x minus 2, we'll say that's minus 2. We would go up 3 and over 1, which would put us somewhere like here. Okay. So, these two lines cross about right here. That's the point we're looking for. We want to know the x and y value of that point. Or in other words, the solution to this system of equations. So it's going to be an x value and a y value that are true for both equations. And there's only going to be one x and y value that's true for both. So how do we solve that? Well, you can graph them and estimate. Like if we had graphed these really neatly, we would estimate, that looks like maybe about, I don't know, what did we do there? I don't know, about 3 and 5 or something. So estimate about 3, 5. Okay. So you can do it on a graph, but unless you're really, really detailed and exact with your graph, then you're just estimating. So there's a way to find the exact answer algebraically. So one way to do that is called substitution. So what we do is we take y equals this, okay, and so since y equals all of this stuff, wherever we see a y, we can substitute it with this, because they're the same, they're equal. Makes sense? If y was 5, this would be 5. They're the same value. So if I see a y, I can take it out and put this expression in. So go to this next equation, and I've got a y there. Well, I can take out that y, and I can put in this expression. So now I'll have something that says 1/2 x plus 4 equals 3x minus 2. Because I just put this thing in place of the y. And now I'm just solving an algebraic equation. So we want the x's on the same side of the equals. So I'm going to subtract this 1/2 x from this side to cancel it out. And then I'm going to subtract it over here to keep the equation equal. So now I'm going to have 4 equals, because this is gone, so 4 equals 3 minus 1/2 is 2.5. We'll just go with decimals for now. 2.5x minus 2. Okay. Well, now I want to get this number over here with this number, so I'm going to add 2, opposite, so that cancels that negative 2 out, you get 0. Then I balance the equation, I add 2 over here, so I have 6 equals 2.5x. Then we're running out of room here, but we're going to divide by 2.5, because that's the opposite of multiplying. 2.5. 6 divided by 2.5 is something. What would that be? That would be 2 and 2/5. Okay, 2.4. Okay, so that's my answer. X equals 2.4. Okay, so that's the x value. I estimated 3, so we were pretty close. So 2.4. Now finding the y value is a lot easier now that I know the x. I can just plug my x value in for this value or this one in either equation. So I'll use this one. So 3 times 2.4 equals 6 plus 7.2. Yeah, should that. And then minus 2 equals 5.2. So 2.4, 5.2 is my exact solution. Useless, but I hope it helps a little bit.